Good afternoon. I'm going to present to you the concept of conditional power. Conditional power is the power of rejecting or accepting the rejecting the null hypothesis given number at that particular point in time. So it is related to the questions which we have. That means when you analyze the data, at every interim analysis, you would ask the question, what is the guarantee that at the end of the study, I would get the same significant result, same trend, which can happen at the end of the study? Can it happen? If I don't find any difference, what is the guarantee that as I go ahead collecting more data, that I would reject the null hypothesis? Do you understand what I'm saying? If there is a difference, the question to be asked is, what is the guarantee that the same trend will exist till the end of the study? If no difference, you would ask the question, what is the guarantee that what is it that can I gain more power over time? These questions have to be addressed. So therefore, that point in time, supposing I have planned 5 interim analyses. At the 3rd interim analysis, I have a significant difference. So I'm ready to reject the null hypothesis. But there is something which is itching in my mind. What is the guarantee that the same trend will exist if I continue the study further? You don't reject the null or stop the study based on one interim analysis significant result. At least you would do one more interim analysis and see whether the trend is existing or not. So therefore, the question to be addressed is, when you do interim analysis, say for example, out of 5 analyses, I did the 3rd analysis, there is a significant difference. The question to be asked is, what is the guarantee that the trend will exist if I continue the study? 1. If no difference at that level, what is the guarantee that there will be a difference as I go ahead and accumulate data and do the analysis? That is 4th and 5th analysis. Or it is not going to improve at all. Do you understand this? That is futility. No difference. Should I continue the study or not? So therefore, the probability at that level which you estimate should address these questions. Should we stop for benefit or should we stop for futility? Is that clear? So the purpose of conditional power analysis in interim analysis is this. So there is a good amount of work which was done by Marimuthu, who is doing PhD now in McMaster University. In fact, Kant only got him that placement there. That's already there. So this is the data. What we have done is that we helped ICMR. ICMR did this convalescent plasma trial for COVID-19 patients. So in between, while the study was going on, they wanted to know that really that treatment is beneficial or not. So they asked us to help them to estimate the 2 probabilities. Do you remember? Are we going to stop the study for benefit or are we going to stop the study for futility? The 2 questions have to be addressed. They want to know what is happening, first of all, and what is the probability that we are going to estimate. So I'm not sure whether they really built in interim analysis or not. That you have to go to the paper and see. This we have discussed about it, the alpha error, beta error, and power of the study, etc. The group sequential trial that Kant has presented, This is as you increase the number of analysis, that alpha error increases and so on and so forth. Therefore, this has to be incorporated in the calculation which you deal with. I'm not going to talk to you the calculation details, the formula details. So this is basically whether the obtained current difference is likely to continue in the future as well, if the study continued. If so, then what is the probability of getting a significant result? If there is a positive difference, then what is the probability that we will get the difference? Assuming that the future analysis are going to be showing you no difference, null effect. So even if all the further analysis are going to be insignificant, still we are going to show a big difference. That is called benefit. That is the worst assumption you will have in your analysis. Do you understand what I'm saying? So today you got a big difference. Assuming that the future analysis are not going to be significant, it is going to be zero in effect. And if so, what is the probability that we will show significant results at the end of the study? The next one is, what is the probability of getting significant result at the end of the study when there is no difference in future? That is what I said. This is whether the current difference is likely to continue in future if the study continued. If so, then what is the probability of getting a significant result? Now, let me say the two scenarios if you have understood. And let me skip this one. When you plan the study, we have three scenarios. One is the design effect, whether the physicians or surgeons come together and say, this is the difference that we are aiming to get. That is called a design effect. The delta which you plan in your sample size calculation and put it in the calculation. The second one is that when you do interim analysis, you observe some difference. There is a difference between the two arms. That is called a trend. Please remember the trend. And null hypothesis, as I said, if there is a difference at a particular interim analysis, and assuming that the further analysis are going to be of no difference, if that is the case, that is called null hypothesis. So CP trend is that trend. We said one may rely more directly on the interim data and assume that the current observed value of treatment effect will continue in the future of the data. That is, the trend is going to continue. That is why it is called CT. Null is that one that if you assume a pessimistic scenario, that is no difference between two interventions in the future interim analysis, and it is also called CP under null. Okay. So in future, there is no difference between the two arms. This is, the researchers usually assume the difference in, assume the treatment effect in the planning stage to calculate sample size. So use this also in the calculation to estimate the power. There are three scenarios: no difference, and there is a trend at that level, and the one which was planned used by the physicians, that is called design effect, D. So say, why should we do this one, for an example? This is, for example, you do the first interim analysis, it appears to be very significant. It does not, the confidence interval in the first interim analysis does not touch this null hypothesis line. The second interim analysis coming towards the null hypothesis line, touched the null hypothesis line, and it is getting worse. And therefore, you are not able to do anything at this level. What we are planning is, at this level, can I estimate the probability of what is going to happen at this level here? Do you understand? Let me repeat it again. I'm here doing interim analysis, and I get this probability here. Using this probability, I should be able to tell you that this is not going to be better anymore, even if I do 5 interim analysis. That is called conditional power analysis. This is based on Einstein concept of Brownian motion and so on and so forth, which is not necessary for us. So this is the study which ICMR conducted, that they have involved 39 public and private hospitals across India. At that level, I knew that it's not going to be a positive trial, because the more you involve the study sites, it is not going to work anymore. So I remember I got involved with them on the stem cell intervention for myocardial infarction. This project was given to CMC to monitor, conduct stem cell interventions for various diseases. And this is it got published in BMJ. This is the data. They wanted to study 226 subjects. And once they received 74 subjects and 82 subjects, they wanted to do the interim analysis. So at that time, we were working on this small software to estimate these probabilities. So they asked us to help them in doing this analysis. So if you look at this proportion of death, 23%, here this is 21%. So at this level itself, we say there's no difference between the two. But the question is this: you have three options. One is, what is now the difference is, this is 23% and this is 21%. So the difference is only 2%. You need to say that it's better you stop the study. It is not going to anymore better. So because you stop it for futility. Looks like absolutely no difference between the two arms. If so, what is the probability of that? The next one is, so it looks to me like that, but if there is a difference, what is the probability that there is a benefit, a phenomenal benefit, an overwhelming benefit, you stop the study. This situation here, it looks like we will stop the study for futility. So it is not going to be any better. So what we have done was that we developed this kind of software. It's like a small window. You input your data. We see here, the software will ask you what kind of one-sided or two-sided test, alpha level, beta level, and the planned sample size. So 226 in each arm for the ICMR study. And the interim analysis was based on 74 and 82 subjects. The observed proportions in both the arms are given here. Now you see the results. The Z value for Z value is 0.33, P value is 0.73, interim fractions, and so on and so forth. There are three parameters in the last three lines given here. They are very important here.
Yes,
conditional power under null, that is 0.01, 1.4%. Conditional power under null hypothesis. Okay. And the current trend, if the trend continues like this, what is the probability that I would be able to show them as statistically significant, only 4.2% or whatever. So therefore, you would ask the question, shall we stop the study for futility? It is not going to be any better. Shall we stop the study? Okay. And if I say this, for an example, when ICMR planned the study, they planned with a very big difference of delta. If I use that in my calculation, and that is 38%. So if I continue the study, that 38% probability that I would be able to show that there is a difference. Is it enough? What are the guidelines we have to stop the study for futility, or what is a guideline for probability to stop the study for benefit? There are two questions we need to have. So this is the guideline. If there is a current trend, if the current trend probability is less than 30%, we recommend stopping the study for futility. So what would you do here? Current trend is less than 30%, what would you do? Stop the study for futility. So we are ready to stop the study. It's very poor. Okay. The next one is analysis. The CP null is a very important concept. Greater than or equal to 80%. Then stop the study for benefit. Okay. So this is CP null is 1.5%. We needed more than 80%. So it is not going to be any better. Okay. So therefore, you stop the studies. Our advice to ICMR was to stop the study at that level. So that is 1/3 of the study sample size was completed, but the advice was based on this analysis to stop the study. But anyway, they decided to complete the study and got it published. So I mean, they did not tell me that they had a DSMB, and I'm a DSMB member there. So I just helped them. I don't know what happened after that. So this is, but anyway, the point is that the intervention is not useful at all. Yeah.
No
Yeah.
benefit.
CP null is basically there is a, say for an example, overwhelming difference at this level. Assuming that the rest of the analysis are going to be insignificant. So that is CP null. It has to be 80% at this level. The probability of rejecting the null hypothesis has to be 80% at this level. And assuming that rest of the analysis are going to be 0, not significant, if that is the scenario, then you stop the study for benefit. This is a benefit. There's a big difference at this level. So that is how it works. So this is for the benefit. But for the futility, the trend has to have at least greater than 30%. But here it is 1.5%. Trend is only 4.2%. So this is basically, you can copy this link and put it in your browser and see whether it works. Do you understand? It's very easy. Not working? Try a couple of times. That is their protocol, their model. If I use O'Brien-Fleming method, then you just you analyze the data and estimate the probabilities. Okay. Okay. So that is that you have the data. What do you need at that level? Say for an example, if I use O'Brien-Fleming method, which we have used for stem-cell intervention and myocardial infarction study. So you have, say for an example, third interim analysis. You have the data between two arms. How many have totally been analyzed in each arm and how many events obtained in each arm, and put the data in the calculator, gives you all the probabilities. Then you need to check the summary guidelines and see whether you got 30% probabilities and 80% probabilities and so on. Based on that, you make a decision. Okay. Futility means people, I don't know, can't they to tell us that you are ready to stop the study. Maybe in the next interim analysis, you would stop the study. But the benefit, overwhelming benefit, that I don't know that you immediately stop the study, or still you'll give one more go. So that's something which we need to understand. The conditional power has been less understood for many of the researchers. So this is basically to address these questions, you need to do that. So you can go through this paper, and there are some references we have put in the paper. So you can use it. Do you have any questions now? Yeah. CP under design is always expected to be giving you a very high values, because the doctors, when they use this delta and the sample size calculation, they're very optimistic they would get a better benefit and so on and so forth. So therefore, usually that is not considered as very important. Okay. Your question is, when do I use it? Is that right? It's like the not null, the other one, like a trend. Instead of trend, you use this one. The trend to stop the study for benefit, you have to have trend has to be greater than 80%. Here it is still 30% or whatever. 38% CP under design. Yeah. Yeah. No, if the current trend is 80%, 80, then it must be 100%. The design effect will be, design probability will be much higher. Yeah, that is why always the design effect will be very high than the observed data. That is how it is planned. Usually. Okay. Any other questions? Now, after listening to Kant's presentation,
much faster than they expected. So the result will be less.
this is a good question.
Yeah, it could be the current trend.
We have to think about it. So we have not made anything for the mean and standard deviation. We should be able to make it.
Yeah.
We never thought about it.
Yeah, it could be.
Okay, we'll do it. So this is, I remember I got involved in the stem cell intervention when they started the center and so on and so forth. I drafted the protocol. I wrote this sequential trial for, there are 3 studies planned. One was on myocardial infarction, cell intervention for myocardial infarction, stem cell intervention for rheumatoid arthritis, stem cell intervention for stroke. 3 studies planned. I got involved with Dr. Jose, then head of cardiology. We wrote the proposal. The proposal was sent somewhere to US for evaluation. And I remember I wrote that the stopping rules based on Pocock method. They asked me to correct it using O'Brien-Fleming method. So we corrected it. So now when I look at it, so the question is, which method do you use? If you have to plan a proposal, something like that. Yeah, so you have to say, what would you suggest? Say again. A priori. In a statistical method, you'll have to write. You write the proposal. No, this method, the stopping rule methods. No, you have to say in the protocol, it is a priori. You let us say, I will do this, I will use this method. Which method do you use? I would still use O'Brien-Fleming method. So I don't know whether I would be able to do that one PHA.
They're stopping guidelines. The people call them rules, but they're not.
Then you should use it. So my only concern is that should we wait for 50% of your time? So it's a 2-year study, you have to do the analysis at the end of, is it 50% of your time, the study 50%. Time? So you have to wait for 1 year to do the analysis, first interim analysis, which is a long time period.
The information.
If the treatment is really effective, the implications of it should be depriving of not giving that medications. I don't know, that's too short. If it's a longer period, then you have a problem. Okay. Right. Any other question? We'll stop. Yes, sir.
The critical appraisal is at 4.
No,
This is
I think can't, there's a question whether open
Oh.
label trial or blinded trial, is there any difference in the interim analysis planning and so on? No. No.
Since it is to be specified a priori, in case it is not specified a priori, does it mean the trial has to be completed and then only analysis will occur?
No,
No,
it is a priori.
no. If you have a
So,
DSMB, they will ask you to do things, even if it's not in your protocol.
In academic institution, we always say we have two standards. One is a postgraduate student doing a research. You don't ask him to follow audit trail software and so on and so forth. At least we will be happy if he enters his data then and there. And
doesn't
it is
make up the data.
analyzable, and he has the records and so on and so forth. That is academic situation. It is expected to be cheaper, and except the fact that he has to be very honest and so on and so forth. And so therefore, sometime when I started analyzing their data, you find the odd values coming out. Then he'll say that middle of the night I entered the data. You get wrong values and so on and so forth. But regulatory trials, if you plan, there is a budget, there's a team working and so on and so forth, then it is a serious business.
One of the reasons they were asking this was like the conferences proceedings from abstracts of conferences. Many times, like as a reviewer for that, you end up getting from good institutes data which they claim is the clinical trial. The interim analysis protocol not specified, but interim data will tell. So does it vitiate that trial in total? Ideally, it should. And
we encourage them to present. Then we don't go through, there is a protocol at all in the study and so on and so forth. Just unless it is, usually nowadays the IRBs are very good, IRB approved proposal and registered in the clinical trial registry. That is enough. So, and I come from this region where PGs are not allowed to do any research, randomized control trials at all.
Yeah. No, but for example, if you're doing, doesn't have to be a regulatory trial, but if you're doing a trial that's a serious trial, then publishing, and so not an exercise in a class or whatever, but you're doing a serious trial, interim results should not be presented in public at all. And so the group that does it, and interestingly, there are people that do it, and the ones that do it are surgeons. If you look at surgical trials, they tend to publish interim results. And this is not done in cancer research. It's not done in cardiology. It's not done in gastroenterology. It's not done in ophthalmology. But surgical trials, I don't know why they publish it, because if you publish the result, then you've unblinded the investigators. And now the results are known. But so typically it's not done, but I've seen it done a couple of times.
Yes.
Say again? Okay.
Some people say there's going to be a 1-year outcome, 2-year outcome, and 3-year outcome for a clinical pharma trial. So they will have one RCT published at the 1-year mark, and then they'll have a second RCT published. I mean, the same outcomes followed up for 2 years and 3 years. When doing systematic review, suddenly you find it looks like 3 separate papers. It's actually the same study. They're giving the 1-year outcome as one paper, and the 2nd-year outcome is another paper. And then they mask it by changing the first author becomes the 3rd author, and the 4th author becomes the 2nd author, those kind of things.
The issue there is once that first year analysis and results are out, and you're still providing intervention, you can manipulate.
No, the intervention is over. Just the follow-up.
That is different.
The follow-up 1 year, the 2nd year follow-up, the 3rd year follow-up.
long-term follow-up, then
Yes.
that's okay.
That is acceptable.
But it's an intervention.
But we should not do an interim result publication and say that we should not do.
That you should not.
Sir, one question like this ICMR trial you showed, interim analysis, it didn't show any benefit, but still it went on to have been published in a leading
Because
journal.
this is to say that other people should not try this intervention anywhere else. Because wasting time.
No, but there are some studies, like I'm just giving an example. There is one leading study, plateau trial for ticagrelor against clopidogrel. That is published in 2008 in NEGM. And still controversy is going on because all the subsequent studies didn't show any benefit of ticagrelor. So it has been found that it is like AstraZeneca pharma company driven.
Yeah.
And even interim analysis was done. Everything was done in that trial, but they are not reporting the data. I mean, they are not disclosing the data now. And now I have heard like they have stopped replying to the questions also, the investigators. So it is makes a big difference because some studies have shown significant side effects of ticagrelor, even mortality and all, everything they have hidden from the initial trial. So
I remember when there is a negative study, I remember somebody used to tell us it should write it up and tell the people that it is negative. Therefore, other people will not waste their money, energy, and so on and so forth, and doing the same study again and showing that there's no effect at all. The one which you are saying is they have shown some difference, and later on the other people could not show that difference. That is a different story. And in that perspective, this is good that they were able to show that plasma intervention is not significant. Yes.
Is this calculator based on the brain or some sort of?
This is actually, I remember there's no interim analysis planned. Because as a subject number, what a sample size is not a problem for them. This is to curiosity to see whether should they need to continue the study or not. So it's 1/3 of the subject. There's no planning in that study. If you read that paper, you would know. There's no formal interim analysis. If there is a formal interim analysis, then you have shown that absolutely it is not going to make any difference. Then the people might ask, it's unethical. You should have stopped the study a long time back. So they did not. This is the kind of analysis which we did and said they should not have continued the study, ideally speaking. By the time probably that other results would have come to them, and then they wrote it up.
What method you have used? Three methods which you were suggesting, that O-brain.
Sir, no method planned here. If you plan, say for example, 4 interim analysis, then the method comes. Whether you want to use which method, because each interim analysis analyzed the probability to stop the study to make it a significant varies. Do you understand this? O-brain method, the first interim analysis will start with a very high p-value, second one, third one. There is no formal interim analysis planned in the study. So it is. Why did we do this? They wanted to know. There's no formal interim analysis planned in the protocol. To see whether the curiosity, you wanted to know whether there will be a difference, is it worth continuing the study or not. By the time they wanted to finish up that analysis, stop the study, the rest of the results would have come. Because you see many centers and so on. They got the paper. So it is negative result.
No, but one clarification is the Data Safety Monitoring Board chooses which type of approach they want to use for interim analysis. They could do the group sequential approach, which is a frequentist approach, or they can do the conditional power approach, which is more of a Bayesian. So here you estimate those conditional power and the null of the current trend and the design, and you can either look at it in an exploratory way, or decide right in your stat for the interim analysis that if I go, what is it, over 80%,
Yeah, yes.
I will stop for this.
Yeah.
And if I go below this, I will stop for futility. Or if it looks promising, I will do continue. And you can say, I'm going to do it at 25%, I'm going to do it at 30%, I'm going to do it at 35%, I'm going to do it at this. Or you have to write the SAP a priori in the charter of the DSMB. So remember, there's two SAPs. This is not the SAP at the end of the trial. This is the SAP for interim analysis. And you can choose now, some of them, we have one board that chose to do the PHRI boundary and conditional power. But they use the conditional power as a descriptive one. So that if they cross the boundary and they said, I don't want to do that 90-day business, I want to look at this, and they want to do that. So the board decides how they want to use these things. These things, as I said, are not prescriptive. These are guidelines. People think that they are rules. They are not rules. We talk about them as stopping rules. We really should think of them as stopping guidelines. That something is happening, let's look carefully at the data. Most boards never look at it as a rule. I had every board that I've been on, always they look at it as guidelines. Nobody says, no, the regular study protocol should mention we are going to have a DSMB. We mentioned that they are going to be doing interim analysis, mentions that they're going to be looking at maybe O'Brien Fleming, maybe PHRI, maybe Pocock, maybe conditional power, maybe. So the PI can write it in the protocol, but when you have your first DSMB meeting, they will decide, I don't like what you have there. We want this. And I want these other ones too. And I want that other one too. No. No, you don't need to know that. You don't need to ask.
Just address only this one.
But it's halfway through. It is still open for discussion because the time is only halfway through. And some board member may decide, I would like to wait a little bit longer. It's up to them to decide because it is a guideline. It's not prescriptive. The advice to continue.
Does the DSMB suggest sample size re-estimation, or does the DSMB tell the sponsor the study is underpowered? You decide if you want to increase the sample size and this much it should be, or the sponsor independently makes a decision?
So they will not tell them that you're underpowered because that unblinds them as to the result.
So then when often we see papers where reports that had an interim analysis to decide
Okay, so I will
sample
talk
size
about
was
adaptive
re-estimated.
trials. Adaptive trials will have already in the protocol have specified when they're going to do the sample size re-estimation, at what stage, when there will be the go more
Or
or
no
go
go.
or not go more. They have a go, no go situation when it's promising, when it's not promising. Adaptive trials are adaptive by design. It's not ad hoc. We are not getting this, let's make an adaptation. That's not adaptive. Many people think that, oh, I'll do adaptive trials, I'll start changing things as we go along. That's not the way to do that. We have a session.
I remember that, so we presume that event rate is going to be 10%, say for an example. Supposing the event rate is what you see after a couple of analysis, interim analysis, you got 8% or 7%. At that level, committee has to say that we need to increase the number to get enough number of events. No, not possible.
Yeah, so the committee, first of all, will not tell you. When you the investigator, you know the overall event. Because you see the data, but not by treatment. You don't know the extent. What you do know is the extent.
Yeah.
If you say, oh, yes, sample size calculation was 20%, and now we see 8%. Then they tell the statistician of the study, are we going to have much less power? And then they do this, again, still blinded to the actual result of the test. They will now decide, maybe we should increase the sample size or extend the follow-up
Yeah.
to get more events. And they have to now talk to the sponsor.
Yeah, money.
We're going to give you more time to do this. DSMB is not the job.
Not the DSMB. DSMB, DSMB that time looks at the data. The proposal says the event rate is going to be 20%, but you land up with the say, event rate of 10%. The question will be asked. No, I'm just saying that, is it right that in this way, if you go, we are going to be underpowered? So therefore, at that level, we need to correct our proposal. That is how.
So the DSMB is not to help you fix the problem. They will not necessarily do. They expect you as the investigator to know that you have much lower power because you have a low overall event. Even with the design, your design initial power, you will know. Because you know the overall event rate. That
Yeah.
under the design. You don't have to know the real data. You as an investigator realize, oh, my power is 40%. I'm going to do something.
Yeah.
The only thing you can do is go to the sponsor, beg, please give me more money, give me more time.
Yeah. In that sense, it is adaptive.
No, sir. That is, the DSMB will not tell you to do that.
No.
Also saying that the PI must realize that the
No,
study
no,
is
no.
underpowered. He has to write to the ethics committee and ask for a modification of this protocol, increase the duration of follow-up or increase the sample size.
No,
But
no.
the DSMB won't tell him that you should have.
No.
done
This is DMC is DSMB is out of
this.
picture.
No, it's the PI himself has to realize that.
Yeah, has to realize the design is adaptive. Sequence design, sequential trial is in a way is adaptive. If you have money.
To be adaptive, he has to go to the IRB again and modify
Yeah.
and said it was
So.
Timing is adaptive. And it is
already in the protocol.
We are going to look at the event rate after we have 100 patients or after we have 100 events. And if the event rate is this,